All right, we're going to continue adding polynomials, the horizontal method, just like what we were doing before when we were simplifying algebraic expressions. So this last example in doing the horizontal method, what we have is a subtraction problem, which means we're going to have to distribute this subtraction. You remember I told you to put in a 1 there and then say plus a -1, and then so we could distribute this negative all the way across, and then we can say that this is a negative 5 and a positive 4x and a positive 9, and that way we can combine like terms. So we have 7xy squared here, and there are no more xy squared terms. This one is an x squared y term. That's one's different, so we'll underline it twice. And then we have an x term here, and we have a x term here, so those are alike. And then I have a constant here and a constant there, so those are alike. So I'm going to put the -5x squared y first, because x squared y is a third degree term, and xy squared is a third degree term, but the x squared to the second power is higher than the x to the first power, so it would come first if we were ordering these properly. And the next one is the 7xy squared. And then the next one, we have -2x's and positive 4x's, so we have a positive 2x now. And finally, we have a 3 plus a 9, which gives me a 12. And now I have combined the like terms. I've simplified those, that algebraic expression, or the fancy new term for it, I've added the polynomials. Now our next method of doing this is a vertical method, and this requires that we order the polynomials first, distribute our subtraction, right, remove grouping symbols, and then we stack them in columns where like terms are over like terms, and then we add them together. Notice that this is always adding. So I'm going to go ahead and write these down, and then we'll be adding those together. All right, I've written these down so that we can go ahead and add these together. So the first thing I'm going to do is I'm going to change this one to addition by adding the opposite of this and then distributing this -1 that I've gotten. So this will be a -5, this will be a -x squared, and that'll be a positive 2x. Now I'm going to go ahead and order these as I write them down. So this is first degree, second degree, and 0 degree. So I'm going to write the second degree term first, -2x squared, and then plus. Always remember to put a plus in between each term. No matter if there's a sign there or not, you put a plus between them. And then plus 3. Now I'll go ahead and order these and stack them. So I'm going to put my 5, my -5 as a subtract 5 underneath the constants, my positive 2 as underneath the x's, and my -x squared underneath the -2x squared. And now remember, we're always adding when we do this method. So we have 3 plus -5, 5 minus 3 is 2, and it is negative. 7 plus 2 is 9, and those are x's, so 9 x's. And we don't want to forget to put a plus in there when it's a positive. And then a -2 and a -1, 2 plus 1 is 3. And these are x squareds, but they're negatives. And there is our sum. And remember, these are always sums, always. Okay, now looking at our next one, we have a sum, so that one's going to make it pretty easy. And I'm just going to go ahead and stack these. Now, the thing with this one is that you may not think there's much to do for ordering, but there is. Ordering also means if there's missing degree terms that you make sure you leave spaces for those. So you see when I stack these, I'm going to put the 9x squared underneath the x squared terms, and I'm going to put the -9 underneath the constant terms. But that leaves me with a blank here in the middle. Now I don't suggest you put anything in there because that can be confusing. So I'm just going to leave it blank. And then 7 plus -9 is a -2, and then x plus 0 is x, and then plus in there so you don't forget it. 1 of these plus 9 of these makes 10x squared, and that gives us our sum of our two polynomials. Or another way of looking at this is we just added two algebraic